Hello, and welcome to my Minecraft solar system revamped about the size of the solar system. In my previous thing, one block represented a tenth of an astronomical unit, which is 15 million kilometers. In this one block represents 100,000 kilometers. So this is the sun. Ooh, pretty ball. And I've got some special sticks here. So one block represents 100,000 kilometers. And to make this simple, the center of the sun is at point 00 x and y, and we're going along in the x-axis. So times the x-axis by 100,000, and that's how many kilometers we are away from the center of the sun. I'll keep that on. And now you'll notice I have some special sticks. These sticks can control my speed. First I've got light speed, which light speed in physics is called c. Well, the constant for it's c. And you got 2c, 5, which is 2 times it, 5c, 5 times, 10 times, 50 times, 100 times, 250 times, 500 times, and 1,000 times the speed of light. So let's better get on with it. You want to travel from the sun at light speed? Ready? Let's go! Yeah. This is actually slower than walking. If you notice, it's actually minus 30%. Yeah, so each of these torches are 5 million kilometers away, which would be about 5 blocks in the previous one. Okay, let's go to twice the speed of light. So this is faster than walking. So the speed of light, if you did not know, is 300,000 kilometers a second. And so we're going about 3 blocks a second. Well, we're going 3 blocks a second there. Let's go 5 times. You can see the x-axis going up. Can we see the sun? No. Okay. And what's coming up? Right around 580. 579 to be exact, is Mercury. This is not the scale, unlike the sun. If it was real scale, it would be 0.39 pixels, which a pixel is not a pixel on your screen, it's a pixel of Minecraft's engine. So this is a standard 16, well, it's the standard pack, so it's 16 by 16 texture pack. So it'll be 0.3 pixels, well, actually basically 0.4 pixels across, so probably about that big. Okay, and now the torches are gone. They're 100 blocks apart, which they're 100, they're 10 million kilometers. Was it 10 million? It's over 10 or 100. Yes, 10 million. Let's go 10c. 10 times the speed of light. Go. And now we've already got to, I was too bothered to place down torches, so now we're going at 500 blocks every time. And we are here at 1082 Venus, also not to scale, and it will be 1.9 pixels across, so about here. Let's go. We're back at speed of light times 10. And here's Earth at, what's that? 1496, which would be 2.3 pixels across, which is about that. And 4 blocks away, 400,000 kilometers, is the moon, which would be 0.27 pixels across. Might also notice here, this is SOHO, which is a space probe. I might talk about that. Okay. It's a solar observatory looking at the sun. It's at L1, Lagrange point. I might go into Lagrange points in another video. So, now let's go back to on a speed of 10C. So we're going about, what, 30 blocks a second or something? Each of these torches are 500 blocks away, which is 50 million kilometers. And here's Mars, which would be 0.54 pixels across, and so it's not scale. So at 2279. Are we going 10 times? So that was the inner solar system with its 4 planets. Now you'll notice the outer solar system is a fair bit bigger. This is the start of the main asteroid belt. So around 3081. That's 500 blocks, I think, or is it 1,000? And what's this? You're going, it's Jupiter, isn't it? Well, it's not. This is Ceres. Like my last video, I include the dwarf planets, because if I include Pluto, I've got to include all the other dwarf planets. So Ceres, the largest object in the asteroid belt, would be 0.07 pixels. That's tiny. And I can't get out. Okay, back up to 10C. Now let's go. Around 5,000 blocks. This is the end of the asteroid belt. Pretty close to 5. Okay, so now the torches are 1,000 blocks away, or 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 100,000 kilometers. Some strange graphical glitches. It actually looks like I'm sort of traveling backwards. Well, that's because we're going so fast. The frames are each frame. The thing's gone in front. The same with the edge of the block is a little bit further in front each frame than what it was. You'll notice this when cars are driving, you actually sometimes, well, when you watch a video of cars driving past us, you might actually see their wheels go backwards or stop. That's actually just the frame rate issue. So we are at 7,300. And here we are, finally at Jupiter, which is not exactly the scale, but it would actually be 22.8 pixels, and a block is 16 pixels across. So it would actually be about from the hitbox edge of this sign to the hitbox edge of this sign. So it'd be about that big across. And if I can go back in. Now, let's go 50 times rather than 10 times because that took a while. And we only got to Jupiter, which was, what, 8,000 blocks or something? We're already at 10,000. Saturn is, well, Jupiter's at 5 astronomical units away, so 5 times the distance of the Sun. These are all calculations are done by the semi-major axis of their orbits, which is the average between their periapse and the... Oh, here's Saturn. Saturn, which it would be 19.2 pixels, which would be about the edge of this, the hitbox of that sign, to the edge of the block. Okay, back up to 50. Yeah, the average between the periapse and apoapse, which is the periapse and the apoapse is... The periapse is the lowest part of an orbit. The apoapse is the highest part. You can see my Kerbal Space Program series for more information on orbits. Boom. 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 So we're going about, what, 150 blocks a second, maybe? I can't judge time. Maybe 200 blocks a second. We're going pretty fast. We're going 50 times the speed of light. Boom. 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 So we passed Saturn. Also Saturn, its diameter. Oh, I'll talk about that later. Here's Uranus, which would be, I haven't said the size, but it's about the size of this creeper head from across. So we're at 28,700 blocks. Whoop. Now back up to 50. And that's actually the diameter was actually the diameter of the planet, not with the rings, by the way. Because the rings are pretty wide themselves. So we are at 33,000. $34,000. It's pretty crazy when you can't, when just a couple of seconds, 1,000 blocks pass. It's crazy. Boom. $40,000. This is a pretty big scale. 41,000. But it's definitely 42,000. It's definitely not the largest scale model of the solar system. One, technically it doesn't have any distance at all because it's on a computer. But oh, look where we are at 44,980. We have Neptune, which is about the size of the zombie head, which is the exact same size as a creeper head. So they're almost the same size. Neptune's a little smaller. And here's the start. Sorry for that. Here's the start of the Kuiper belt, which is the outer asteroid belt, with the icy bodies. So now let's go 100 times. We get some graphical glitches because the chunks aren't loading in quick enough. So the three above, the three sticks above, it gets worse graphical glitches than this. So mainly you can't see the torches go past, but you can see that number go up. That X number. Whoop. Here we are at Pluto, everybody's favorite dwarf planet, and probably the only one anybody knows, except astronomers and science people like me, which would be 0.3 pixels, which is a bit bigger, which is fairly bigger than, well, 3 times bigger than Ceres. Whoop. And so, at light speed, so this, to walk back, it'll take probably about 6 hours. Back at 100C. Whoop. And here is Hormea. Not scale again. This would be 0.09. Same size as Ceres. 100. Whoop. Chunks didn't load in. Okay. And sometimes you get teleported in walls like that. Because you're going so fast. It gets worse with higher velocities. Whoa. And at 68,300 we have Make. Not make. I have to specifically say that. Which is 0.1 pixels. So far, Pluto has been the biggest dwarf planet. Whoop. Okay, good. Yeah, that stuck in a wall there. This is a pretty long trench. Whoop. Man, I've done this before, but I didn't have these sticks. It takes forever to get out of here. This is the end of the Kuiper Belt. But technically, there are objects past the Kuiper Belt, and they're still part of the Kuiper Belt. This is stuff this is what the data I got. It's harder to find where a asteroid belt starts and ends, because there's more than one object. And they all have different eccentricity of orbits, which means how circular their orbits are. So they all go in and out different amounts. 90,000. We're going pretty damn fast. This is still a long video, being like 18 minutes long at this point. Oh, I think we went past it. Oh wait, no we didn't. Ah. We have to keep going. I used MC Edit to make the trench, and it took a bloody long time. Oh, that was, It took a bloody long time to make that trench there. And here it is. The last dwarf planet Eris, which is 0.18 pixels across. Was Pluto 0.3 pixels? I can't remember. If so, that was probably wrong, because Eris is the biggest dwarf planet there is. Whoop, holy crap. That's that's a 100C stick. But there is an object further out there that I've built. I'm not going to go that far. I've got a teleport to it. All the way back. Okay, we're back here. And you probably saw it. I tried connecting these two trenches. This is the same Actually, it's on the wrong side. That's funny. Okay, this is way not to scale. It's Voyager 1. This is the furthest man-made object away from the Sun and the Earth. If you notice, we're at 195,400 blocks. That's a long, 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 long way. And so if you would want to walk here at the speed of light, well, walk back to the Sun, it takes about, I'm saying very roughly, I can't remember, but it's around plus or minus probably like 5 hours, 36 hours. 36 hours. Light's slow, yet it's really fast. And thanks for watching.